Welcome back. So for today we're going to be treating sword, and I'm going to be giving the rules guarding sword. And if possible, I'm going to be solving a few questions on sword. So sword is simply the square root of irrational numbers that cannot be expressed as a rational number. Sword is simply the square root of irrational numbers which cannot be expressed as a rational number. So what sword simply means is that when you want to find the square root of an imperfect square, it is simply a sword that you're getting. For instance, 5 here is not a perfect square. So when you want to find the square root, you are getting a sword. So this is a sword. We have our root 7, root 2, there are many of them. And we can even have something like 3 root 2. So all these numbers are in swordic form and they are called swords. Now I'm going to be explaining the rules guiding basic operations in sword. First of all, we have the multiplication law. So the multiplication law simply states that when you want to multiply two swords, even if the digits in the sword are different, you can multiply the both of them together. For instance, where if you want to multiply a root m times root n, that this is equal to root m times n, which is equal to root mn. So this is all multiplication law is trying to say. So now let me solve an example with this. If we have root 3 multiplied by root 2, it means that this is equal to root 3 times 2, which is equal to root 6. So this is all that this law is trying to say. Now the next one is division law. Division law. So for division law, we are having that root m divided by root n is equivalent to root m over n. Let me solve an example to clarify us on this. Let's assume that we have root 10 divided by root 2. So this is simply equal to root 10 over 2, and we are getting root 5. Now the third one is the addition law. The addition law states that, or rather the addition law goes like this. When you have a root m to be added to a, or to be added to b root m, that you're going to be getting a plus b root m. So now you have to take note of something. When it comes to multiplication law, you can multiply even if the terms are different or even if they are the same. But when it comes to addition law, you cannot add them if what is inside the bracket is different. So it means that if you come to this multiplication, if you have something like 2 multiplied by root 2, you are going to be getting root 2 times 2, and this is root 4. And you know that the square root of 4 is 2, so you'll be getting 2 here. But when it comes to addition law, when you have something like 5 root 2 to be added to 5 root 3, it cannot go. It means that this same thing that you have here is going to be the answer. But as long as what is inside here, as long as the number carrying the roots are the same, it means that you can add. So assuming what I have here now is 5 root 2 plus 5 root 2, it means that I can add them together. So I'm going to be getting 5 plus 5 root 2. So this is going to be equal to 10 root 2. And also assuming what I have here is a 7 root 3 plus 5 root 3, it means that I'm going to be getting 7 plus 5 root 3. And this is equal to 12 root 3. So addition law only applies when the root, the number carrying the roots for the two expressions or for the two terms are the same. When they are not the same, you cannot add them together. And if you have something like, let's assume that you just have the sword, root 3 plus root 3, maybe you have something like this, you can also add them together, because when you have something like this, it means that 1 is here and 1 is also here. So you're going to be getting 1 plus 1 root 3. So this is equal to 2 root 3. But once the number carrying the roots are different for the two expressions, you cannot add them together. This same thing applies to subtraction law. Subtraction law. So subtraction law is the same thing as addition law. The only difference is the sign. So in subtraction law, when you have that a root m subtracted from b root m, you are going to be getting a minus b root m. So now let me solve an example on this. If we have 10 root 3 minus 6 root 3, it means that you're going to be getting 10 minus 6 root 3. And 10 minus 6 is 4, so you'll be getting 4 root 3. And then if you have, let me solve another example. If you have maybe 6 root 3 minus 10 root 3, it means that you're going to be getting 6 minus 10 all root 3. 6 minus 10 here is minus 4 root 3. So the rules, everything for normal subtraction and normal addition is the same thing that applies here. The only difference is that you have to take note of the sword. That's the only difference. So having explained the rules guarding sword, we're going to be moving over to conjugation and rationalization of sword. So I'm going to start by explaining conjugate of a sword. So a conjugate of a sword is simply the least number by which the sword will be multiplied by to change it. For instance, if I have root 3, the conjugate of root 3 is going to be root 3 again. And the reason for this is because root 3 is the least number that I can use to multiply this root 3 in order to get a number. Now let's multiply it. If I should do root 3 multiplied by root 3, I'm going to be getting root 3 times 3, and this is equal to root 9, and root 9 is equivalent to 3. So that means root 3 is the smallest number that we can use to multiply root 3 in order to get a complete number. That is a whole number without sword. Now, if you want to conjugate a number that maybe has a sign in it, maybe addition or subtraction, all you have to do is to change the sign. So if the expression has plus sign, all you have to do is to change that plus sign to minus sign in order to conjugate it. So if you have an expression with plus sign, a sword with plus sign in it, the conjugate is simply that same expression with the opposite sign, that is minus sign. Now let me solve an example now. Let's assume that we are given 2 root 3 plus 7, and you are asked to conjugate it. The conjugate of this sword is simply going to be equal to 2 root 3. Instead of having a plus sign, I will now be having a minus sign, so minus 7. Now let's multiply this and see what we have. So we have 2 root 3 plus 7 in bracket multiplied by 2 root 3 minus 7. I'm going to be having 2 root 3 into everything that I have here, which is 2 root 3 minus 7, and then plus 7 into everything I have here to get 2 root 3 minus 7. So 2 root 3 multiplied by 2 root 3 is simply going to be giving me 4 root 9. Then 2 root 3 multiplied by minus 7 is going to be giving me minus 14 root 3. And this is it for what is in this bracket. Now I move over to the next bracket. My plus sign. 7 multiplied by 2 root 3 is going to be giving me 14 root 3. 7 multiplied by minus 7 is going to be giving me minus 49. Now I'm going to be adding or subtracting. Now since we have minus 14 root 3 here and plus 14 root 3 here, we already know that these two is going to be giving me a 0, so I can just easily cancel them out to make things easier for me. And now all that I have left is going to be 4 root 9 and this, which is minus 49. As you can see, root 9 here already has a square root, so I can just find the square root to make it a normal number. So square root of 9 here is 3, so I'm going to be having 4 times 3 for this one here, minus 49, and 4 times 3 is 12, so 12 minus 49. 12 minus 49 here is equal to minus 37. So I'll be having minus 37 here. And this here is my answer. So that is it for conjugation. Now we'll move over to rationalization. Now rationalization of surd is mostly used to eliminate the denominator when you are trying to solve a fraction, or when you come in a fraction and the denominator there is a surd. And it's almost the same thing. To rationalize a surd, a fraction surd, is to simply multiply both the numerator and the denominator by the conjugate of the denominator. Now let me solve an example. Let me write this down to show that we've moved over to the next one. So let's assume that you were given a fraction, maybe 5 over root 3. Now as you can see, the surd here is in the denominator. So to make things easier for us, the best thing to do is to rationalize this fraction. And to rationalize it, all we have to do is to multiply both the numerator, which is 5, and the denominator, which is root 3, by the conjugate of the denominator, which is root 3. And from what I gave here, the conjugate of root 3 is still root 3. So all I have to do is to multiply this by root 3 and multiply this by root 3. And I'm going to be getting 5 times root 3 is 5 root 3. Then root 3 times root 3 is going to be giving me root 3 times 3. And this is equal to 5 root 3 root 9. And root 9 here is 3. So I'm going to be getting 5 root 3 all over 3. And this is it. The same thing is also what applies when you have a denominator that has maybe a sign, a positive or negative sign, and you want to rationalize it. All you have to do is find the conjugate of that denominator, use it to multiply both the numerator and the denominator. And mind you, even if the numerator has a surd, for rationalization, we are based on the denominator. Now, let me solve this other example. Let me call this example 1. Let me solve this other example. If I have 7 root 5 all over 7 plus 3 root 3. Now, as you can see for this question, the numerator has surd and the denominator also has a surd. So to rationalize this, all you have to do is to multiply both this numerator and the denominator by the conjugate of the denominator. Ignore the numerator. So now the conjugate of this denominator here is 7 minus 3 root 3. So use it to multiply both the numerator and the denominator. Now we multiply. 7 root 5 multiplied by 7 is going to be giving me 49 root 5. My minus sign, which is here. So 7 root 5 multiplied by 3 root 5 is going to be giving me 35 root 15. And that's it for the numerator. Now we move over to the denominator. 7 times 7 is 49. That is this. Now 7 multiplied by minus root 3 is going to be giving me minus 21 root 3. Plus 3 root 3 multiplied by 7 is going to be giving me plus 21 root 3. Plus 3 root 3 multiplied by minus 3 root 3 is going to be giving me minus 9 root 9. Now if I should simplify this, I'm going to be getting 49 root 5 minus 35 root 15 all over 49 here. Okay, as you can already see, this has a minus sign, minus 21 root 3. This has a plus sign, so I can just eliminate the both of them to make things go faster. And then we come over to this one. This is root 9 here. And you know that the square root of 9 is 3. So I'm going to be doing 3 here multiplied by 9. And 3 multiplied by 9 should be 27. 27. So I'm going to be having minus 27. So now for the denominator, 49 minus 27 is going to be 22. So I'll be having 22 for the denominator. And now over to the numerator. As you can see, the number that is in the root, the number that carries the root for this one, and the number that carries the root for this one, they are different. So there is no way we can subtract it. But we can look for possible ways. Now let's assume this here is 15. Okay, no, that's not going to work. So it means that for the numerator, we're going to be having the same thing. So that is it. Now, sword can be a very confusing something, and I would advise that whenever you are done, you should always take notes and try to maybe cross-check before assuming that you've gotten the correct answer. So, I think that would be, oh, sorry, I'm supposed to be having 21 here. Yes, because 7 times 3 should be 21. Sorry for that. So 21 should be here and here as well. So after solving, this here is my final answer. And that's it for rationalization of sword. Please, if you found this video very helpful, make sure to like, share, and subscribe. I also drop information on other topics, tutorials on other topics, and they are usually well explained and well detailed. So if there's any topic you would like me to make a tutorial on, make sure to comment that in the comment section and I'll be very glad to get back to you. Thank you.